Okay, so I think the last time we were talking about we talked about data types, right? That one is very important. So let's just go through it. And then for the each type of Arduino board has its own length of has its own lengths, right? So for the ends, the sign, unsigned, all those, they are a little bit different from the boards differ, right? But the most important thing is that for the board we are using, or for the board I'm using for the Arduino Nano 33 BLE sense, right? A byte is just 1 byte. You guys know what a byte is? 1 byte is what? 8 bits. Easy as that. And then a short is 2 bytes. 2 byte means what? 2 times 8, right? Then an int is 4 bytes, 32 bits, right? But the int, okay, the case that not. So and then we have unsigned int, right? And then you know the difference between int and then unsigned int, right? So I shouldn't bother. And then we have long. The long is what, 4 bytes. So what is the difference between the long data type and the int data type? But you know the difference between unsigned int and int, right? Unsigned int. Who knows the difference?
So one has a negative, one has a sign.
Like the unsigned int and int. We have signed int and then we have unsigned, right? So we are talking about unsigned int and then int itself,
The int is positive.
and then the unsigned int itself.
It ranges from the negatives.
And then signed int itself.
Positive or negative.
Wait, we have just int, right? We have unsigned int. Okay, you guys should go and find the difference. Then you know float, double, stuff like that. These are just the basics of programming, right?
That's it.
And I think the next thing was I think for the Arduino board, I said that in programming the digital pins, you just use the number, right? And then for the analog pins, you use A, then the number, right? So here we are just going to see a simple example of reading a value from the analog pins. I think all we did in the past is that we were reading values or giving values to the digital pins. So how do we read value from the analog pin, right? This code does that, right?
Yes, sir.
And as I said, always just go through. Just if you don't even understand, just go through the code and then use the the English terms right? Because everything here is an English term, right? So use the English terms to be, and then it will really help you understand the code, right? So here, what are you doing? What are you doing here?
Yeah,
Okay, let's start from the loop. What is
reading
the first line of the loop doing?
is reading the values from the analog pin.
Yeah. So you say that the first line of the was constant by its analog pin is equals to A2. So we have given A2, we are reading the analog pin A2, right? Understood? Analog pin A2. So the first line of code in the loop is we are reading the analog pin and then we are giving it to the variable, the int variable var, right? So it's an integer number. Understood?
Yes, sir.
What does the second line of code do? The second line float volt is equals to val times
Second or 12.
in the loop, in the loop. So this is actually very, very important. This formula here. So now, if I'm coming, if you were paying attention from the beginning, right? I said something about the analog pins, right? So now, if I read the value, let's say I read the value analog read. I use analog read to read the value on the analog pin, and then I give it to the variable int, an integer variable, right? And then I print that value. What do you think it will give me? What number will it give me? What will be the range of the number? Positive what? But what will be the range from? Or can you give me any number at all? What will be the range of the number if I read the analog pin? So if I just give you the codes, do you guys think you can understand them? If I just give you the codes, I mean, okay, right. But you guys are telecom engineers, right? So I said that each analog pin is connected to an ADC. You know what an ADC is? It's what? I think I mentioned this some time ago. So we have an ADC, right? We have an ADC where each analog pin is connected to. The analog pin takes analog signals or it gives analog signals, and then our board is a digital board, right? The MCU does not understand analog kind of signals, right? It only understands digital signals. So the analog pins will pick the analog signal, but it has an ADC. It will convert the analog to digital, and then it will give that value to the MCU, and then it will now understand it. So we have to convert it, right? Understood? And then, as I said, the ADC, the analog signals around actually they range from it can range from anything to anything, right? It can have a wide range, but with our ADC, we need to limit the range, right, of our analog signal. So I think you guys know this kind of signals. You guys know that these are analog signals, right? Then we compare them to digital by just digitizing it. Something like you guys have seen this before. You guys are telecom engineers or something like that, right? So now we need to know the limit of where we can go. So all the signals that fall above the limit of the ADC, it will be chopped off. And then all the volumes that fall below the ADC, it will also be chopped off. And then the ADC has a range. So here, what we have done is that this formula here, this 1023 here means that our signal or our values can range from 0 to 1023, right? So it picks a digital, it picks the analog value, right? And then it converts it to digital. And then it's restricted to a particular number. It can't go above the number. It can't go above 1023. That's what we have done. So we take the value, so the analog signal erase will have a value. It will have a value between 0 and what? 1024, right? And then the we want to read the voltage on the analog pin. So what do? I said the pins on the Arduino board is 3.3 volts, right? So all we do is that we take that value, right? The value times 3.3, the value times 3.3 divided by 1024 will give you the voltage value on the pin. Understood? That's easy, right? So that's what it does. Then what does the next code do? The sprintf. I don't think you guys will know this one. What does the print do? in case I'm printing, right?
Change the value.
If I use print, just print. Print, right? Print can print a string. I'm printing some number, some letters, the boy or whatever. So I'll just put it in quotes. I just use print into brackets. I put it in quotes there, whatever, right? And then it will print it for me. Now print cannot mix up. It cannot mix up data types. So if I want to print, let's say I have a value, I have an integer value, right? Int A. I have a float value, float B, and I have a string, right? I can use one print statement to print all of this, right? It's impossible because the print only prints either a string or I can just print in print into brackets A, and then it will print the value for me, whether it's float or it's integer. That's all it can do, right? So here, if I want to print my ADC value, I want to print the actual ADC values, and then I know that my ADC value is an integer value, right? It's int val, the analog value, right? The ADC value is an integer value, and I want to print the volt. The volt too is a floating point value, so float volt. So these are two data types I want to print, right? And then I want to print some string also. I want to print ABC, then colon volt, colon the volt value, the value, the val value, and then the volt value. Understood? It's impossible to do this with to print to use just one line of code to print all of this. If I want to do if I want to use the print value, if I want to use the print function here, how will I do it? I want to print something like this. I just want to print this. ABC colon whatever. How will it be done with the print statement? Do you guys understand what I'm saying? Hmm? Print the so I have a print statement to print either a string so I have the function called print in Arduino, right? Right? Used to print strings or integers, but it cannot mix up the values. It cannot mix up, it cannot print within one statement. I cannot print a string and I cannot print a value within one statement, right? Now, what I want to achieve here is that I want to print something like, I want to print on my console, right? Something like ABC, and then I print the value here, this val, right? ABC val, and then so val, and then I print the value, right? I print the value here, and then I also print the I print the volt value, this volt here, this floating point value, right? And then I print the 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 integer value. So it will do something like ADC and then something volts, right? And then something, then something, it will be probably 0 point something or 0 point, like it will print a floating point value also here, right? So it means that I'm printing different data types, a floating point value, I'm printing a string, and then I'm printing an integer value within one statement, right? So how do I do this with the print? The print can only print a string or a number, but not both. Do you understand?
Yeah.
So how do I do that with the print?
So you add F to this.
Uh-huh.
You can change the integer to string, so you can print it.
So you assign the integer print to the letter and you the data you want to print different data types in one line. Yeah. In Python, I know in Python you add F to the print.
Printf,
Print F.
and then it will do it.
You can print a
Different
string
data.
together with an integer in one line.
Yeah, probably in Python. Yeah, that can be done in Python and even in C. So printf2 in C, it can be done. Here, it cannot be done here using the print, right? So first of all, I'm printing a string. This is but you know that if I do something like in C or in Python, whatever, if I do something like percentage %G, it means what?
Modulo.
Huh?
Percent is modulo.
Who said that? Who said it is modulo? I mean, like where did they say it was modulo?
Ah.
Nah. It means that the number I'm printing is decimal. Percentage is decimal, right? If I print something like 0.2f, percentage, once you see a percentage, something like a percentage here, I am printing some kind of data type, right? My first data type was int. So integers are made up of decimal numbers, right? So I put percentage d to print the decimal number, right? If I put percentage f, I'm printing a what? A floating point number, as easy as that. Now, if I do something like percentage 0.2f, what happens? Just think about it small.
The float should have one decimal.
Two decimal places. It's as simple as that. So if I just print percentage f, it will print probably 0.1234, like a lot of numbers. But if I want to restrict the number of decimal places to be 1, 2, 3, or 4, I will just use 0. If I use 0.2 here, it means I'm printing a floating point number with only 2 decimal places. It will just cut the rest off. Understood? Easy, right? So now, if I'm using the print, right? I can achieve this aim, but I have to use different lines of code, the different lines to do my printing. So first of all, I have to do print into bracket. What am I printing? My first is a string, ADC, right? The ADC is a string, so I do something like this, ADC, right? And then my next one is percentage %G means that I'm printing this value. It cannot be done within this line. It cannot be done within this line. So what I have to do is I have to close this one. So I just do this one, ADC, and then that is one line of code. It will just print ADC. Then I have to come to my next line of code, right? And do again print. Now it's a value I'm printing, right? So the val value, it will print the value var, the val value itself, right? And then the next one I'm printing is volt. Volt is a string. It cannot do that within that line of code, right? So I have to come and do it again. I have to come and do this again. Print volt. Understood? I, are you following it?
Mm. I kind of saw a code where they had like the print, but then they had string concatenation where they changed the val or the value to a string and printed it on the same line using additions like with the
So
plus.
like
So
how
it's like ABC, the string plus string with the brackets, then they put the val there plus whatever follows. So it was like
okay, probably
one
I want
line.
to wait, probably. All right. So but the point is that once you're using the print, you are using more lines of code. Probably here. So after here, you have to come and print again the volt value, right? Print volt, 4 lines of code, right? And this is not effective. 4 lines of code for just doing this is not effective. So you can use there's another function called the sprintf. Have you seen it? Sprintf to be able to print mixed data types within 1 line of code, right? And how does that one work? So all you have to do is you have to create a container to store all the values and the strings you are printing. So you must know how many of them there are. So here you see from the second line of code on top, I have car message msg into bracket 30, right? So what does that mean? Sir? Like what does that mean? The second line of code. The second line
30,
of code.
30 characters.
Yeah, so I've created space. I've created an array of 30 characters. Right? So I've created a space where I can store 30 characters. A character is 8 bits, probably, right? Understood? So now it means that if what I'm printing is more than 30 characters, it means that it will chop off the rest of it. So I must know uh, the number of the number of letters and numbers I'm printing within one print, right? So here I'm doing 30 because I'm just it will be here. This 1, 2, 3, 4. The space is also part. So 1, 2, 3, 4. And then this 5, 6, 7, 8, 9. So just 9. Understood? So I can use 30 or I can even use 10. It will work. Understood? So I just do that and then I come into the code and write sprint msg and then I write all of this. And then it will store all of these values within the msg, right? Then I can use the normal print, serial.print msg, and then it will print it in the code for me. As easy as that.
So
Understood?
if you put all of them in the comments, the comments, won't it print as a string?
So that's where this one comes in. Percentage D, percentage. Once you see a percentage, it's a formatted value, right? So it will print this value. So you see that ABC percentage D. It will come here and print this value and put it here. The exact value of this one and put it here. And then bold, the percentage it will print this bold value, put it here. Understood? Any question? Any question? So this, what makes Arduino programming easy is that you see that everything is a library, and then you call a function within the library. If you don't understand it, so if you come, in case I take this code here and the bar is go to analog read to like an analog read, and I don't understand, I just have to Google analog read, and it will just explain it for me. It will just bring out the Arduino page that will explain what analog read is and then how to use the analog read function. It's as easy as that. So you can just go and try all the other codes out. Understood?
Yes, sir.
All right. So this code, I could have tested this code, but should I test it or we don't have that much time, right? Okay. So this is the next code. Should I explain or I should just jump over the codes?
Explain.
Explain. Eh?
Explain.
Oh, what's that? Oh, okay. So here, what are we trying to achieve now? We are still on the analog reading of the pins, right? So what we are doing is that we want to read, we want to see how long it takes to read a number of analog values from the analog pin. How long does it take? That's all, right? So all we do is that we have we declare variables, the start time and then the duration. Have you seen it? Unsigned long, start time, then duration, just some kind of values, right? So what we do is we come into the loop and then we use the macros library. So what the macros library does is that once you power on your Arduino board, right, it gives you the duration of time the Arduino board is on. So if let's say I want to read a value from a digital pin, or and I want to read a value from an analog pin and see how long it takes to read that value, all I can do is that I can, before I read the value, I just do start time is equals to micros. So it will take that time the Arduino board started and store it in the start time, right? And then I read the analog pin several times. So here we are reading the analog pins several times. So for int is equals I is equals 0. We read it a number of times, and then after you have done reading, all we do again is we find the duration, right? We pick the duration is equal to the micros, so it means that the current time minus the start time. Easy as that, right? And it will just give me the duration. Do you understand? Any question here? Any question? Any question? Any question? Any question? So should I continue? Okay. So here again, you need to be careful when you are using integers and floating point numbers. Now, you need to be able to write efficient codes, right? So now, if you're using an integer number, or you're doing calculations that involve integers, and then you're doing calculations that involve floating point numbers, right? The time it takes to do those calculations is different. Which one will take longer? The floating point arithmetic or the integer arithmetic? Hmm? Which one will take longer to execute?
Floating point.
Why?
Floating points, they are decimals.
Okay, so we're, pardon?
Floating points, they are decimals, so to take longer.
Okay, so, yeah. It's that easy, right? I mean, you are dealing with a arithmetic that has a decimal and then dot something, right? So how to actually go about that takes a very long time than just doing simple integers, right? So whenever you can, you must instead of using floating points, you must actually use integers, right? And then this code, these two codes here, the first one does floating point arithmetic here. So it does the value times 3.3 divided by 1023, right? It does floating point multiplication, and here we are doing integer multiplication, and then we are just trying to find out which one takes longer. So these two codes, that's all they do. You run this code, and then it will give you the duration of time it takes to do that calculation in floating point, and then it also, and then the other code will run, and then it will give you the duration of time it takes to do integer mm, to do this calculation here. Understood?
Yes, sir.
And then obviously the first code will take longer. So you can go and run it on your own and see, then understand how it does it, right?
Yes, sir.
Now bitwise operations. Now our next, I think from next week, that's what we are going to now go into the microprocessor itself, and then we are going to study something. We are going to study some things like this, and then I think you guys have already done things like this, so we'll go through it quickly. You guys know what AND gates are, right? Or gates. Okay, XOR gates, all those kind of stuff. So if you know those kind of stuff, and then you can combine those kind of gates to make a digital system, right? Yes or no? Pardon? It doesn't matter. I think that you guys have done it somewhere before. I think digital logic design or digital something. Probably. Yeah. But here, let's just go through some simple bitwise operations. So if I have A, right, I say A is equals to decimal system. Right, so I should be able to, so by in this week, you guys should learn how to convert between numbers from decimal number to binary number.
You can't use calculator.
Huh?
You can't use calculator.
The calculator takes longer than using your brain set.
Use when I say.
Okay, so for 60, if I take the number 60, right? 60 is decimal, right? The binary of 60 is what? 111100. So pay attention here. So this is the binary of what? 60. Right? So in case I convert this to binary, this is what it should look like. Right? Now, if I say that this is 1, 2, 3, 4, 5, 6, this is 6 bits, right? If I say that this is 8 bits, right? I have to add two zeros here, 0, 0, and it is a set. You know that if I add zeros to the beginning of a number, it's still the same number, right?
Yes.
So if I say this number is 8 bits, all it means is that I have 0, 0, then 1, 1, 1, 1, 0, 0. That's 60 in decimal. So if I want 60 in hexadecimal, right? What will it be?
3C.
It's on the board, right? But it won't be in the exam sheet, so you have to 3C. Why 3C? Why 3C? So hexadecimal means that the number must range from 0 to F. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, right? So now it means that it is taking 4 bits. So if I have this number here, what hexadecimal does is that it brings the number down into fours, right? We have a 4 here, 4 bits here, and then we have 4 bits here. That's all it does. It breaks the number down into fours, right? And then it picks this number. This is 1100. In hexadecimal is C, right? This is 0011. In hexadecimal is 3. So the decimal 60 in hexadecimal is 3C. As easy as that. Do you understand? Do you understand? Okay, so if I have a number like 50, if B is equals to 15 decimal, right? And I have this as mine. So 15 in binary is just 1, 1, 1, 1. And then if I say it's 8 bits, then it will be, I have to add zeros here. So 0, 0, 0, 1, 1, 1, 1. So if I say I want this number in hexadecimal, what will it be? Why F? So as I said, you have to break this number down into fours again. So this is 4 bits, right? 1, 2, 3, 4. 1, 1, 1, 4 bits. Another 4 bits. 1, 2, 3, 4. So 1, 1, 1 in hexadecimal is F. It's 15 F, right? So it will be F, and then this 000 is 0, and then 0F just means F. Easy as that, right? So now, if I say A and B, right? What will be the answer? For those of you who know what an AND gate is. So this is my A, this is my B. If I say A and B, I'm doing A and B. What will be the value? Some of you said you know what an AND gate is, right?
Yeah, we do, but I don't remember. We have to bear in mind. Yeah.
Okay, that's fine. But the whole thing is that, so you for an AND gate, right? You have probably, if you have a two input AND gate, you know what that means. This is how an AND gate looks like. Two inputs means you have one bit here, one bit here, and then it has one bit output, right? Then you have to know the truth table of the AND gates to be able to do this A and B here. You need to know it. It's very easy, but you need to know the truth table of the AND gate. And what is the truth table of an AND gate? If I have my input A here to be A, my input here to be B, and then my output to be, let's say, Y, I need to draw the truth table, and then the truth table looks like this: A, B, and then Y, right? So I need to give it all the possible values of A and B. So A can be 0, B can be 0, right? A can be 0, B can be 1. A can be 1, B can be 0. A can be 1, B can be 1. Easy, right? You guys understand why it is so? Now, after I've had all the possible inputs of, of the AND truth table, I now have to come and find Y. So 0, 0 will give me what? 0, 1 will give me what? 1, 0 will give me what? 1, 1 gives me what? Right? Easy, right? So the AND gate, anytime if one of the inputs of an AND gate is a 0, the value is automatically 0. Both inputs of an AND gate, A and B, must be 1, 1 before the output can be a 1. Easy, right? So now, if I say A and B, what will be the value here? So this is A, this is B. So what will be the value? So all I have to do is A and B, we are doing bitwise operation. So one operation at a time, one operation at a time, right? So I take this one and this one. What will be the value here? I take this one and this one. What will be the value? This one and this. This and this. This and this. This. So the A and B will be 0, 0, 0, 0, 1, 1, 0, 0. Easy. So this is just what we mean by bitwise operation. And then there are so many of them. There's AND, or, XOR, shift left, shift right, stuff like that. Understood? So then, any question so far? Any question? Any question?
No, sir.
So the next one is what? The next one is how do we store our variables in memory, right? When you write when you declare an integer value, or stuff like that, it gets stored in memory, and then how that number gets stored in memory is also very, very important, right? And then how that number is transmitted, in case we are transmitting the number from one point to another, right? How it is transmitted, or where do we start from in the transmission is also very important, right? So we have something we call the Indianness of a number, right? So the Indianness of a number just means that if I have an integer value like, okay, if I have an integer value like 0a, 0b, 0c, 0d, right? This is a 32-bit integer, right? And then all these numbers are in hexadecimal, right? So how do I store this integer in memory? Where do I start from in storing? Do I start from the left side or do I start from the right side? Understood? So the Indianness is about where to start from to store the number within the memory, right? So in case I'm storing that number, in case I have a 32-bit integer, uh, what 0a, then what 0 what b, 0c, 0d. So this is very, very important. So here within the Arduino boards, right, the memories are, this is how memory is arranged. We have, you have your memory like this, right? And then let's say your memory is like this, and then you have your memory width, right? Very important. And then you have your memory depth. So we have the width, and then we have the depth, right? Are you paying attention?
Yes, sir.
So this is the memory. You have your width, and then you have the depth, right? Right? So the width is just how many bits it can store within one location. So these are the locations. So every memory has memory locations, right? And then you can start naming from the bottom up. So here I'll start with memory location 0 from the top here. 1, 2, 3, 4, 5, 6, 7. Right? So these numbers 0, 1, 2, 3 up to 7 are the memory addresses. So if I want to address something within this memory, like I want to address a value within here, I have to reference this number 5, and it will pick the value from here, right? So the depth of the memory, the width of the memory is how much it can store within one location, just one location. Within location 0, how many bits can it store, right? So normally in the memories are like 8 bits. It can store 8 bits within one location, right? And then the depth of the memory is how many 8 bits are there within the memory. As easy as that, right? So we have the width and then the depth. Very, very important. And then the width and the depth, has to, if you check your PCs and stuff like that, for your RAMs, right? The width of your RAM and then the depth of your RAM will give you the total number of bits your RAM can store, right? So it will be the width times the depth, right? That gives you the total number of bits or bytes or whatever your PC or the PC on your RAM can store, right? So within your Arduino, it's always 8 bits. So if I have this number 0A, 0B, 0C, 0D, and I declare it as an integer, I know that an integer is 32 bits, right? So it means that what that means is that I cannot store this whole 32 bits within one location. What will it do? It ought to break this 32-bit number down into 8 bits, 8 bits, 8 bits, and store it within the memory. Are you understanding? So how does it break it down? So this, you know that this is, I said this is a decimal number. So each number is 4 bits. So it will break this one down into 8 bits. So this is 4 bits, this is 4 bits. So that's 8 bits, right? So it will break it down into 4. So it will break it down into bytes. You know a byte is 8 bits, right? So it has broken this one down into bytes. But now, how do we store it? Do we store this number here or we store this number here? Right? So that's where the Indianness come in. So each PC or each each kind of device has a way it stores it. Some stores it as Little India, That's one of them. And one store is a big Indian. Understood? So when we talk about the little Indian, right? The little Indian will take the last value, right, and store it in the first address. So if I say, oh, I have a number, 82-bit number, 0A, 0B, 0B, and I want to store it in memory location. So here, I can store this one in memory location 0, 1, 2, 3, 4. 0, 1, 2, 3, right? I can store it in this location, right? So I say, and I want to store it in memory location 0, 1, 2, 3, 4. So where will each value be stored when I'm using Little Indian, right? So memory location 0 will store 0D, right? Memory location 1 will store, then it starts from here, then this one will store 0C, 0B, and then 0A. That is Little Indian, very, very important, right? So when you have a system or a machine that uses Little Indian, this is how it stores it. It takes the least number and stores it in the lowest address. Big Indian is just the opposite, right? So what the big Indian will do is that it will take the least number and store it in the highest memory location. Understood? Do you understand? Any question? Any question? So I say we have Little Indian and Big Indian, right? So what I just explained or is just Little Indian, and I say the opposite is for Big Indian. So if I have Little Indian and I have a number, an integer which is 32 bits, and I want to store it in memory using Little Indian kind of system, right? I take the least number, and then very important, the least number in digital system is what is known as the LSB, least significant bit. The highest number within a digital system is known as the MSB, most significant bit. Understood? So if I'm doing Little Indian, I will take the LSB, the least significant bit here, and store it in the lowest address. The lowest address here is 0, right? So I store 0D in 0, then 0C here, 0B next, and then 0A here, right? Now for Big Indian, I will take this same number, the LSB, and store it in the highest address. So now the highest address is 3, right? So for Big Indian, I'll take 0D and store it in 3, 0C and store it in 2, 0B and store it in 1, and take 0A and store it in location 0. That's easy as that. So the exams, this is how easy it will be. I give you a number, just store it in memory location 0. You see how direct that is. Do you understand? Shall I continue? I think, and I explained this one already, right? The pulse width modulation. Do you know what that is? The PWM, pulse width modulation, right? I said that for the digital pins, right? I think I said that you can only give it an on and an off. You can only give the value 0 to it, or a 5, or a 3.3 volts in this way using our Arduino board, right? So it can only be two values, 0 and 3.3. It cannot be in between. So I think I was even explaining that how do I, if I have an LED connected to the pin, right? I can only turn the LED on and off, right? But how do I dim the light within the LED?
Turn it off really fast.
Yeah, I think I explained this already, right? So what you do is the what you have to change is you can only turn it on and off, and then this is how the digital signal look like. It's either a 5 volts or 3.3 volts or a 0 volt, right? It cannot be in between. This is how it just looks like, right? A 1 or a 0, 1 or 0, and then we say that from here to here is what we call the period, right? So you see that it starts from here, it goes from high to low, then from high to low, then from high to low, right? So this is what we call this here, this line here is called the rising edge, right, of the signal. This here is called the falling edge, right? This here is the rising edge. This here is the falling edge, right? And then from one rising edge to another rising edge here is the period. I think you already know this. And then I can calculate the frequency using the period. I said the frequency is equal to 1 over the period. Right? Now, the, the time it turns on, you see that here is on, right? Here is off. Here is on. Here is off. Right? The number, the time it turns off is what we call the duty cycle. Understood? I think you guys have done this somewhere like that in telecom.
Yeah.
Right? So the time it takes, the time it stays on for is the duty cycle. Right? So I can, if I say I have a system which has a duty cycle of 50, and then the duty cycles are measured in percentages, 50% or 20% or 30%, right? So if I say I have a system which has a duty cycle of 50%, what does that mean? 50% duty cycle.
It means the from the one of the weight of the high is equal to the weight of the low.
Yeah, so 50% just means that it turns on for 50% and turns off for what? 50%. So from one positive edge to the other positive edge is 100%, right? So the number of times the number of time it turns on is the duty cycle. And if I say 50%, it means that it turns on 50% and turns off 50%. What if I say it has a duty cycle of 20%? Hmm? 20, 2080. As easy as that. So it should be something like this. So not drawn to scale, but understood. So 20% here, 80% there. Right? So another simple exam question. So I just draw this one for you. Then give then give here. Then say okay. Let me see. I will say from here to here there is 20 milliseconds, right? Then from here to here is 10 milliseconds. You see, so I can say probably find the period in seconds, right? Then I can say find the frequency in hertz or something. Yeah. Then I can say calculate the duty cycle in percentages, right? So you see how easy that will be. Do you understand? Should I continue? So within the Arduino board, right, you can go through the example, basic and the field example to see how the PWM works. So if you have the board, or if you can actually if you can actually simulate it, you just go through examples, basic and fade, and then it will show you how it does it using the pulse wave modulation. Right? Now, how do we communicate from one Arduino board to another, or between two devices, right? That is our next thing. So I have two Arduino boards. I want to send data from one Arduino board to another Arduino board, right? How do I do that? So I have two boards here. I have a board, this one board. I have another board, right? So I should be able to send data from one board to another. And then there are a number of ways I can do this. Right? I can use what is known as the two-wire interface, TWI. Very important. It's a two-wire interface, right? So why is it called two-wire interface? Because we are only using two wires. So I will have to take one Arduino board and another Arduino board, and then I take two wires and connect them. So I'm connecting one pin, so just one pin to a pin on the other board, and another pin to another pin on the other Arduino board, right? But the most important thing is that in a two-wire interface is that, right? One must provide the clock. I must provide the clock. So one wire is the clock, and then another wire is data. So if I want to send data, I have to activate the clock and send the data through one of the wires, right?
But you said some time ago, you said that USB is two-way. You said that USB is two-way.
Yeah.
So it means it works like how the USB works.
Yeah. But it's a bit different. So I think you will see the difference. So this one is what we call the two-wire interface. Just two wires. There's no buffers involved. There's nothing involved. Just wires interconnection, right? Do you understand? So I said one wire is the clock, and then one wire is the what? Data, right? So if I want to send data, I have to use the clock, right? Activate the clock, and then I send the data through the data wire, right? So let's say I have this Arduino board here, one. I have Arduino board here, two, right? I want to send 1010 this number. So you know that this is just a single wire. So it means that it's a serial kind of interface. It can only send one bit at a time. It can't send two bits, only one bit at a time, right? So you can only send one bit at a time. So if I want to send 1010, right? What do I do? So I said you have to first activate the clock. The clock signal looks like this. So your clock signal always looks like this, with 50% duty cycle, right? And then your clock, sometimes it always runs forever. So you design your code in a way that your clock will always run forever. Now, as I said, this is what we call the rising edge of the clock, right? The positive edge. Then we have here the falling edge. This is the rising edge, falling edge. So we have rising edge, falling edges, right? So I said again, here is the period, right? So if I want to send a number, right, I have to wait for the rising edge of the clock, and then I put the number on the data line. So if I want to send a 1, right, so what I do is that I wait for this rising edge here, right, and then I send the 1, right. My next value is what? Is 0, right? So I have to wait for this. So after I send this one here, I have to wait for this rising edge, and then I send the 0. Are you seeing how it's working?
Yeah.
Then I have to wait for another rising edge again before I send the next value is what? A 1, right? I have to wait for another rising edge before I send the 1 again. And then I have to wait for another rising edge before I send the 0. Right, so this is the data. So once I do this, I'll be able to effectively send 1010 to the other board by using the rising edge of the clock. I have to always wait. If the clock goes high, then send the value. Then I wait again because it has the clock will go high and then it will come down. Then it will go high again. Wait for another rising edge, then send the value. Wait for and send the value. Understood? So that's how the two-wire interface works.
So when you're using the you're not connecting the base one to the laptop or
No,
the
no,
computer.
you are connecting two Arduino boards, not the laptop.
So then it means the clock and then the data wire, like their duties are automatic.
What do
Because
you mean by that?
you said you need to activate the clock.
Yeah, yeah,
So
yeah. So like within your code, you have to now write code for to do this. That's what you do.
and you just said you don't connect the base one to the computer.
So the aim of the two wire is to be able to communicate between two Arduino boards. This one Arduino board, this another Arduino board. So I program one Arduino board on the PC. I just program it. Program another one using another PC. So I program one as the transmitter, and I program another one to receive. So now I'm not actually connecting one PC to another PC directly. I'm connecting the board. So then I connect a wire from one Arduino board to another Arduino board. Understood?
Okay, so you've left coded instructions on both boards.
On both boards, and then you are letting both boards talk to each other.
Okay.
Understood?
So when you're done, what do you use to check the feedback? Like, what do you use to check the end result of the transfer data between the two boards?
That one it depends on you. It depends on how you write your code. You can use the LED on both boards. Oh, if done, blink the LED on the board. Or if done, then if I want to see the output itself, I need to connect the PC actually to all the board and see the console. I send data from here to here, and then it will receive that data and print it on the PC for me. That one it depends on you. Understood?
Yeah.
So this this is just a code to the this is just a code to send data using the two-wire interface. Right? Should I explain it or I should just continue? You guys will go and understand on your own.
I understand.
Okay, okay.
So then why don't you invite him to explain it?
He explained it. He said I have to input the code. One will be set up as a receiver, one will be set up as
So
a
what else
transmitter.
did you explain?
He said you can search yeah.
So here, this is the transmitter code. And this is the receiver code. Pardon?
Let's say
Okay. So I continue, right? So now we have
easy, make me okay.
and but he says like he understands. So if you have any problem anytime, you just go and see.
Direct to me, I'll direct you.
Are you doing it too?
You speak to explain you.
So now another form of communication is the I2C or I2C. You guys have heard it before, probably somewhere. But what happens is that the Arduino board always has, or the Arduino board has integrated sensors, right? It has some form of integrated sensors within them, and then you know that the board itself it has a CPU, which is a chip, right? So we have different chips. I think I explained the last time that we have different chips integrated within the Arduino board, right? So we have the board itself, the MCU itself. Then we have sensors, a lot of sensors. We have temperature, we have humidity, we have some other sensors, and then all of these sensors are chips, right? On the Arduino board, right? So how do the MCU communicate with this chip? Because the MCU controls the CPU on the Arduino board controls all of these sensors. But how does it actually talk to them? It uses what is known as the I2C interface. The I2C interface is also like the two-wire interface. The I2C interface also uses only two wires, one for the clock, which is the SCL, that's the clock, and then we have one for the data, right? But here, the most important thing is that these wires are called buses, right? Those two wires are called buses. And then why are they called buses? They're called buses because a lot of devices can communicate using those same two lines. It's like you taking a lot of people can take a bus, right? So that's why it's called a bus. So you can connect a lot of devices to one one CPU, right? So here the I2C uses what is called a master slave kind of interface. We have one device or one device known as the master, the other device is known as slaves. Understood? So it's like master slave interface, right? So as I said, another here again we have two wires. One wire is for the clock. The same way, the master controls the clock. So if the master wants to send data to any of the slaves, it will also just activate the clock like how I did here, and then it will send the data through the SDA line, the data line, to the slave, right? But you know that there are so many slaves like here. We have master one and slave one, two, three. So how does the master communicate with slave one and then slave two and then slave three? How does it know that, or how does even slave one knows that the data can, because as you can see, all the lines are connected together. This SDA line is the same SDA line here, is the same SDA line, right? And the clock lines were the same, right? So how does a slave knows that this data is for me? Who knows?
And you have to depend on the number of bits that being sent.
Now, the bit that does not indicate anything, or the number of bits will not indicate anything, right? So we have so many slaves connected to just one master. All of them have the same line, the same data lines. It's sending the data through the same line to all of them, right? But how will I know that, or how will this slave know that, oh, the master is talking to me? And then the most important thing is that the master can send data to the slave, and then the master can also request the slave to send it data. So the master can say, oh, you the slave, I want you to send me data, and then it will send it. So how which slave will it use, or which slave will know that the master is talking to me when all the wires are connected together, right?
So I think
Uh-huh.
each slave will have to be assigned a specific role.
Role.
Yeah.
What do you mean by role?
Um,
Like maybe this slave is in charge of this one is in charge
In
of
charge of
this.
what? Because all it's sending is data. All it's sending is some bits, 10 10 10. Yeah, but of course, each slave, like as I said on the MCU, each slave has a function. But one is a temperature sensor, one is humidity sensor, one is another sensor, and then there are different sensors. So each slave has its own purpose, right? But the whole thing is that each slave is hard coded with an address, right? So slave one will have an address, probably 01. Slave two will have address over 10. Slave three will have 11. Now, in case I'm using the I2C bus, right? One master can address up to 127 slaves. So it means that we have 127 unique addresses. Each slave has a unique address. So if a master wants to send, they've all agreed on how to send the data. So if the master wants to send data to any of the slave, he first of all send some number of bits, right? Probably some 8-bit number. He sends some 8-bit number. And then each of the slave will receive this 8-bit number. And then each of the slave will compare this 8-bit number to its hard-coded address. If it matches, then the slave will know that, oh, it's talking to me. If it doesn't match, then the slave will just discard the rest of the numbers coming in. So that's how each slave knows when the master is communicating with it, right? We have hard-coded addresses within each slave, and then the master will send the first 8 bits are always the address of the slave, and then the next one will be the data or something, right? Do you understand?
Yes, sir.
So that's how the I2C works, and then it is used by the Arduino CPU to communicate with all the sensors. Do you understand? And then again, these are the codes for the I2C. And then again, as you said, you guys can just go through the codes, and if you don't understand it, you just Google the library, and then it will just explain to you. As your boy said. So now we have seen that the differences is that the difference between the two-wire interface is that the two-wire interface is used to communicate between two different boards. The I2C is used to communicate within the board, right? It used to communicate with the sensors, right? Now we have another one called the UART protocol. The same exact way. Also uses two wires. And I think I explained the UART interface some time ago. We have the receiver, we have the transmitter, right? On each board. So we have each device has a transmitter and then a receiver. Also just one bit, right? But the most important thing here when you're using the I2C is that we have what is called the buffers. There's a buffer, a transmission buffer, and then a receiving buffer on both ends of the devices. So if I'm sending some message or something from my PC to my Arduino board, the PC has a buffer on its own. The Arduino board also has a buffer, right? So what I do is that once you send the data, right? So if I'm sending data from the PC to the board, the PC will send the data to the buffer of the Arduino board, and then the Arduino board will now read from the buffer of the board, and then it will do whatever it wants with it, right? And I think that is the assignment I gave you guys to go and do. The assignment I gave you, I said read a number like that, right? Then it means that the PC, you will type a number, right? And then the PC will send the number to the buffer of the Arduino board, and then the Arduino board will read that number, and then the Arduino board will do something with the number. I think I said blink something like that, blink an LED for the number of seconds that was entered, right? And you guys have done that already, right? You didn't get what? Pardon? That might be your midterm. So you guys, that's about 30 marks. So what you heard. Now the most important thing is that I talked about the baud rate for the UART, right? I said it has a baud rate of, and I always use 9600. The baud rate is how fast the data should be sent. But there are completely different baud rates. You can use any of these baud rates here. But that will actually also depends on the device you are using, right? Now the Arduino board has a Bluetooth integrated on the board. Now the Bluetooth uses the exact this UART interface, but now it is wireless, right? But the protocol is exactly the same, right? So once you want to use the Bluetooth on your board, you have to actually download some kind of libraries for it, and then the function of the Bluetooth or how it works is it works just like the UART. So it has the UART, the board has a buffer, your phone. So if you have Bluetooth on your Arduino board, and then you have Bluetooth on your phone, then you want to communicate between your phone and then the board, right? The phone has a buffer. The board also has a buffer, so it will send data to the buffer, and then it will read, and then that same explanation is the same, right? I think so. This is the code if you want to use the Bluetooth on the board. You just have to download some kind of library, the hardware BLE serial.h library, right? And then if you want to test it, actually, you have to download another Bluetooth app on your phone, and that will be able to send data to
My laptop.
huh?
My laptop.
Mm.
You have to download an app on your laptop.
Yeah, the same thing. Yeah. Right, and then this is how the Bluetooth works. The same exact as I said, buffers, and then we are using kind of different libraries to actually read from those buffers. Right? Understood?
Yeah.
Now we also have something called interrupts. So in the Bluetooth code, there's a very important line in the code here. You see this code here, BLE.2. Have you seen it? Line 10.
Yeah.
Very, very important, because now you are communicating, let's say, from your phone to the Arduino board, right? Now the Arduino board, as I said, the Arduino board has some kind of buffer, and then the Arduino board, what this serial a BLE serial.pool is doing is that the CPU on your Arduino board has to stop what it's doing, and then it has to check the buffer if there's data in the buffer, right? So the BLE serial.pool will the CPU stops whatever it's doing, and then it's checking that buffer. It's always checking every second, checking until it receives some kind of data. If it receives data, then it will do whatever it wants with that data, and then it will go back to its normal operation, right? So what the pool does is that it's a kind of a way of telling the CPU that there's some data coming from somewhere. So stop whatever you're doing and check, right? And if you check and then there's data, so if there's no data, what will it do? It will continuously check forever, right? And that is not always good when the CPU has to do other stuff, right? Because if you say it will stop whatever it's doing and check only for one particular data that is coming, then you have an issue, right? So what you normally do in computing is that you use what is known as the interrupts, right? So instead of using the pool, always checking, right? You can use some kind of timer, like you know when the data is coming, right? So you will let the CPU do whatever it's doing, and then the timer is counting, right? So if it gets to, let's say, a particular time, then it tells the CPU that, oh, go and check for this data. So the CPU does whatever it's doing, and then the timer is also counting. And once it gets to a particular time, the CPU will now stop whatever it's doing and go and check that buffer, right? Right? That is just that's one way, and then you can also have another way. You can also use a pin to serve as an interrupt, right? So if the pin is high, so you just go and say that, oh, if this particular digital pin is high, right, then the CPU should stop whatever it's doing and do something. That's just what interrupts are. Do you understand? So the interrupt will interrupt the CPU from doing its normal operation, right? So it will come and do whatever the interrupt wants it to do before it goes back to its normal operation, right? So once the interrupt occurs, the CPU stops what it's doing, do whatever the interrupt is saying it should do, and then it goes back to normal operation. Understood? All right. And then there's the code for the interrupt and stuff like that. So you can just go and run it on your own again. As right. Now, now, as I said, what do you want to do for your mission? Do you want to use that one code I gave you, or you want to do another project for your mission?
Another project.
Project.
So another question.
Probably I give you probably I say it's your choice, right? You go and do whatever you want with the Arduino board and come and show it to me, and I give you some marks.
Some map.
With the board itself, like you should use that connect the board itself.
Yeah, so something like that.
Guys,
So what's the second?
Pardon?